So welcome to the scientific method. This is our kind of first video attempt of the year. So if there are any snafus or issues or problems or anything like that, please let me know and I will attempt to get those solved kind of in our next few videos. So to begin with, scientific method. Scientific method is kind of more of a way of thinking than a specific thing. You'll notice that in the scientific method we've got a bunch of kind of different steps. We start with some observations, we might do some questioning, then we form a hypothesis. Hypothesis is a fancy way of saying, well, maybe this is what's causing that, etc. Like when we say there's multiples, usually though they break down to pretty much the same kinds of ideas. The 5-step model is the most common, and 5 steps including making observations, asking a question, make a hypothesis, then you're conducting your controlled experiment, and you draw a conclusion. Those conclusions you can see can be, well, I could accept my hypothesis, meaning, yep, that's true, this is exactly what causes it, or I might possibly say reject it. Nope, it absolutely did not work. We will not use that as our possible explanation. So, how do we make observations? Well, an observation, first of all, can be broken down into 2 different kinds. There are qualitative observations. Those are made about physical traits, characteristics, etc. Those are things like color, shape, texture, etc. Things that you can observe, but you don't really measure, so to speak. Quantitative, then, observations are those that actually are measured. So those would be things, again, like we might say, oh, it's 1 centimeter in length. Versus if I was, describing like a pencil, I would say, oh, it's yellow. All right? So there's different things. Qualitative would be our top ones here. And again, quantitative would be our bottom ones with our numbers. After we've made some observations, we've looked at things, then we want to try to figure out, well, what is the problem? What are we trying to actually do here? So at this point, usually our scientists are going to do some research and try to figure out exactly, what is the problem that we're looking for here. So what do you do when you don't know an answer to a problem? Well, it's the same thing that scientists are going to do. We're going to contact some other people, we're going to ask questions, and we're going to go, hey, what do you already know about this situation? And maybe if we call somebody and they already know the answer to it, then, we won't mess with researching it. Hypothesis, I kind of told you a little bit earlier, is a possible explanation or answer. Key part of this is that it's just the possible one. We don't know for sure that that is true. It's just possible. It also should be a measurable statement. We want to be measurable. We want to be able to actually prove our hypothesis or accept or reject our hypothesis. When we use words like better and best and good, those aren't really measurable. So I'm going to ask you to kind of pause the video here and look at the 2 following statements, and in your notes, circle the one that is the better or more correct hypothesis. First one says the beans are treated with the new fertilizer will grow bigger than the beans treated with the original. And the second one says the beans treated with the new fertilizer will grow better than the beans treated with the original. So pause for a second. Look at, again, what we're trying to figure out and circle the one that is better, that is more correct. For those of you who circled the top one here, the beans treated will grow bigger, that is correct. Okay, so again, the better one, or the more correct hypothesis, would use the term, again, bigger. That's the one that we're looking for, instead of better. The reasoning, again, bigger is something that we could measure. We could see the size of the beans. But better could imply, well, were they more green? Were there fewer weeds? Were there other things? And see, there's a whole bunch of stuff that we can't really necessarily measure. So after we've decided what we want to test, now we got to figure out, well, how are we going to test it? This is an experiment. Okay, this is designing a controlled experiment. The control in a controlled experiment is to give us a baseline to compare other variables to. Control needs to be part of your experiment. So when we say controlled experiment, there needs to be a control group. Again, control is simply what we're going to compare back against. This means you should be easy to follow and figure out, what are we testing here? What am I going to compare to what? So again, how would I know when I have a good experimental design? Well, what we're looking at is, again, is it easily followed, and does it have that control group where we can see and we know what we're testing? Variables. So in our experiment, there are going to be different variables. There should be 2 variables measured and recorded. Usually it's going to be an independent and dependent variable. Independent is going to be the one you're manipulating, and the dependent is going to be one that reacts to what you change. Make sure, again, you always clearly collect your data, especially as we go through labs throughout the year. Make sure you record your numbers, your information, your observations. They should always include the following things. Measurements. Again, part of what we just said is it needed to be measurable. Well, in our measurements, that means labels with our correct units of measurement. So we need to say, was it in seconds? Was it in minutes? Was it in days? Those are all completely different things. If I said it took me 1 minute to run a mile, you'd know that that's incorrect. There's no way you can do it. However, instead of being minutes, let's say I said, oh, it took me 1 hour. Well, I could be going really slow, but that's definitely a possibility that it takes me an hour to do a mile. So what we're going to do next is actually use the scientific method. What I want you to do is on the next page in your notes is a lab called Milky Mess. I'm going to show you a video really quick, and what I want you to do is while we're observing this, you're going to start making a list of questions. And if you can't really think of any, or you're not sure what's going on, this is an appropriate time to ask one of the instructors, either Mrs. Trample or Mr. Baker, if they could help you out with kind of developing that list. Again, make sure when we're looking at this, we're looking for different things that we could actually test. Okay? So, I'm going to go ahead and play the video real quick. While you're watching that, try again to develop a list of questions for me. So again, while this is loading, go ahead and turn to the next page for me and find the spot where you are to record your questions. All right, here we go. Okay, so we have seen those. Go ahead and try to come up with a list of different questions that you might have about what you just saw. I am going to go ahead and post this link on Schoology, so if you want to watch the video again or a couple of times, feel free. But if you have at least a couple of questions, I think I asked for a minimum of 2. So as long as you have a couple of questions that you could probably actually test, don't write things like, what is the liquid? All right, you have a pretty good idea that it's milk, and you have a pretty good idea it was food coloring, and that's a Q-tip. So let's try to again stick to things that you could actually test. Okay, come up with a list of questions, and then if you have time and you want to, try to kind of start writing out a basic procedure. Remember, you want to include a control to look and test against. And if you're not sure how to set that up, again, this would be a great time to ask one of your instructors.